Okay, we left at this exercise 10C, trigonometric identities. We practiced few of these questions till question number 10. To 24. Okay, this is 224, question number 19 and 20. Okay, first it says show that the equation can be written as this. So let me copy this equation and then we'll simplify. Equation is 3 sine square x minus cos square x is equals to 2, and it can be written as 4 sine square x is equals to 3. So what do we have to do? We have to get rid of cos and turn it into sine. We know the identity is cos square x plus sine square x is equals to 1. Yes, Mohammed? We'll come to that. I might need this in part B. I'll quickly just simplify this. So this is minus, when I replace cos, it becomes 1 minus sine square x is equals to 2. So this is 3 sine square x minus 1 plus sine square x is equals to 2. And this becomes 3 plus 1 is 4 sine square x is equals to 2 plus 1, and 4 sine square x is equals to 3. First part. And part B. Part B says hence solve the equation this equals to for the interval minus 180 to 180. Minus 180 to 180. So whenever the examiner asks you to solve it, he always gives you the first line, and we know we can convert this equation into this written in green. So we directly write 4 sine square x is equals to 3, and we have to solve it from minus 180 to 180. This is the domain. So I'm solving for x. Now sine square x is equals to 3 by 4. First thing, square root both sides. This gives me sine x is equals to plus square root 3 by 4, and sine x is equals to minus square root 3 by 4. Can you please use calculator for me? I don't have it near me. And I find basic angle, that is sine inverse. Make sure the calculator is in degrees mode. 3 by 4. Sine inverse square root 3 by 4. And I might get my hands on it. I'm just getting my calculator. Sorry? 68. 60. Okay. Both will be 60. You don't have to go for the negative sign. Whenever you solve for basic angle alpha, you never put a negative sign. So basic angle is basically sine inverse of square root 3 by 4 on both sides, so that's 60. Once we know what the basic angle is, then we decide what to do with the negative and positive sign. In our case, we have to answer them that sine x is equals to positive and negative, that means all. So if I have to see this from negative 180 to 180, negative 180 is this blue thing in clockwise direction, positive 180 is this thing in anti-clockwise direction. So indirectly we've already covered all four quadrants, so we'll be giving answer in all four quadrants. So my first two answers are these angles in green. I know that the basic angle is 60 on both sides, so my first theta would be 60. Second theta, I'm doing this in blue with the curvy line, is this angle, and that is 120. Any issues in these two angles? First theta is 60, second theta is 120. If you punch in sine 60, you will get square root 3 by 4. If you punch in sine 120, you will again get square root 3 by 4. For the third angle, because we are coming in clockwise direction, drawing this in black, this is 60 degrees in anti-clockwise direction, and what do we write? We write minus 60. And fourth angle again, to answer this fourth angle, theta, this is negative 120. Last step, we can rearrange in order. Minus 120. Okay, let me completely remove this. So this is minus 120, minus 60, plus 60 and 120. These are the four angles for which sine x is equals to plus minus square root 3 by 4. If you need practice for the second part, we can do an example. Let's say we have a question cos, after solving everything, we have a question cos x is equals to 0.7. So what will be the basic angle? Alpha is equals to cos inverse of 0.7. What is the answer? Alpha is equals to 45.57. So I'm writing 45.6 up to one decimal place. Now we know the basic angle. Suppose our domain was 0 to 360. So we'll draw our x and y axis. Then we know that cos x was basically equal to a positive number, that is 0.7. It is a positive number, and we know that cos is positive in first and last. How do we know that? Add sugar to coffee. So it is positive in first quadrant and last quadrant. So these are the two angles we will be answering for. So we know the basic angle is 45.6. So first theta is straight away 45.6 and last is 360 minus 45.6. And what is this? Yes. You get marks for steps. It is split in part A and B. This question right here, 7 marks. I would say that these are bonus marks. Question wasn't that hard. Question 22. Find the solution of equation this in the interval minus 360 to positive 360, giving your answers to one decimal place. Okay, let's copy this equation, and that is three cos square x plus 1 is equals to 4 sin x. So what do? We first bring this equation all to cos or all to sine, and this is from minus 360 to 360. So I can see that I can convert cos square but not sine. So this is cos square x is equals to 1 minus sine square x. So 3 into 1 minus sine square x plus 1 is equals to 4 sine x. So yes, we can convert sine x, but the conversion is this. So what would happen if you will change sine? You'll see tan and cos. Still we're stuck. So if we choose to convert cos square, now all the equation is in form of sine, single trigonometric ratio. Getting it? Now I'm rearranging this, taking 3 sine square on the other side, 3 sine square x, 4 sine x is already there, 3 plus 1 is 4, and on the other side it becomes minus 4. Now this is basically a quadratic equation. 3 4 times is 12. So what do we multiply? 6 and 2 to get 12 and 4. So 3 sine square x plus 6 sine x minus 2 sine x minus 4 is equals to 0. Then we take out common, 3 sine x into, yeah, that's a quadratic equation. That's right, that is a quadratic equation. So 3 sine x minus 2 times sine x plus 2 is equals to 0. Now this is the tricky part. When we solve for this, we know that 3 sine x minus 2 is equals to 0 and sine x is equals to 2 by 3. On the other hand, we know that sine x is plus 2 is equals to 0 and sine x is equals to minus 2. Now don't forget what we did in graphs. This was sine x, and we know that sine x ranges from 1 to minus 1, and this is outside 1 and minus 1, so we reject this. So we only solve for this. So basic angle is sine inverse 2 by 3. Please may I have this value? .81, so 41.8 up to 1 decimal place. Now we have the basic angle and we know that sine of x is equal to a positive value. So sine is positive, add sugar to coffee. Sine is positive only in first and second quadrant. So we know this basic angle, which is 41.8. This again is 41.8. Now what do we have to answer? We have to answer it from negative 360 to positive 360. So we go in one side first. Excuse me, just. I'm actually taking class on roadside and inside car. Okay, we know these two basic angles. Sorry, I didn't get it. Yeah, no issue. I was just telling my friend to stay quiet. Okay, now these are the two angles. We know we have to cover from negative 360 and 360 both. So if I start with negative 360, I'm going in anti-clockwise direction. This is my first answer. So this would be, I can see this is 180 plus 41.8. So 180 plus 41.8. So when you add them, you get 212, but with a negative sign. Why so? We are going in anti-clockwise direction. For my second angle, comma, second angle, because I can go till negative 360. This is my second angle, which is actually 41.8 less than 360. So 360 minus 41.8, what is that? 318.2. Thank you. And again with the negative sign. So we're done with the first two angles. Now I'm just removing these arrows so I make it less messy. So these goes away. And now I am moving in anti-clockwise direction. So this is the first angle, which is 41.8 straight away. And second angle would be this angle. And we know we cannot move further because in 360 we are not having any fifth angle. So this is again 180 minus 41.8. And what is that? $138.2. So these are four angles. Quick summary. We knew that sine x was equal to 2 by 3. The question is complete. A quick summary. This was 2 by 3, first thing. Second, sine x is equals to minus 2. We rejected that. And you know why we rejected that? Because sine lies between 1 and minus 1. So we rejected this minus 2. This is outside the range, first thing. Second thing, we know that we are solving for sine x 2 by 3. And our basic angle was 41.8. Because sine is positive in first and second only, so for negative 360, this is our first angle, this is the second angle. For positive 360, you move anti-clockwise, this is your first angle and this is your second angle. So these are four angles within negative 360 to positive 360 for which sine x is equal to 2 by 3 and is positive. Any doubts? Yes, sure. No, that's not necessary. It just it is a good presentation. So for example, you had 110, 170, 350 and 190. So these are your four answers. All four are correct if the basic angle is 10 and sine x is equals to positive and negative both. But if you just write it this way, it is just a better presentation. No need to arrange them. You can save your time. Because our domain was large. In this case, our domain was large. Let me make that clear. For example, we had sine x. Yeah, that's same. They all have the same answer because the basic angle is same. Mahat, suppose you have this basic angle 10 and this basic angle 10. Third basic angle and fourth basic angle. If I tell you to solve from 0 to 90, you'll have only one answer because from 0 to 90 there's only one intersection. You'll have only one answer, that is 10. But if I ask you to solve from 0 to 180, you see you have two intersections and your answer will be 10 and 170. Getting it? If I ask you to solve for 0 to 270, so this is the first intersection, then you have the second intersection, then you have the third intersection. And in the previous case, our domain was negative 360 to 360. And we had so many interceptions for that. Sine was positive. And in anti-clockwise direction for negative 360, we had two intersections. One, then two. In positive for To move till positive 360, we had one interception, then two interceptions. So there were four answers. One last example, this will make it very clear. Suppose these are four angles, 1, 2, 3, 4, and I tell you to solve from 0 to 360, and you can clearly see there are four interceptions. So answers would be 4. But what if I tell you to solve from 0 to 720 for the same question? So this is first circle, you know there are four answers. Then one more circle, so there would be 8 answers. Are you getting the point? So this is it. The first part of the question is always the identity part. Solving it and converting the identity to one trigonometric ratio. It could be cos, sine or tan. Then again it becomes exercise 10C. Let me show you one thing just to motivate you. Why so much practice is required. This right here, we are on chapter 10. So you see 10.4 is simple trigonometric ratio and 10.5 is harder trigonometric equations. Both are equations, the nature is same, the outcome is same, but you would need practice. And then the last part is equation and identities, which we just did. For example, we have this question right here. This is already simplified. Cos 2 theta is equals to 1 by 2. And we are solving from 0 to 360. Let me copy this on the other side. Cos 2 theta is 1 by 2. So cos 2 theta is equals to 1 by 2 and we are solving from 0 to 360. Now this 2 theta is basically what we will be solving for, and theta range for theta it is 0 to 360. If I convert this for 2 theta, this would become 720. For 2 theta it is 720, for only theta it is 360. So coming back to this question, we're finding basic angle first, which becomes cos inverse of 1 by 2. And if I see my triangle, I know that it would be 60. So this is 60. Basic angle is now 60. Now there are two things we need to consider. First, the basic angle. Second, cos theta is equal to positive value or negative value. Cos theta is equals to 1 by 2. That is positive, and now I know that it is in first and last quadrant. Add sugar to coffee. Now whatever the cycles may be, we will answer only for these angles. So for 2 theta, I know that it ranges from 0 to 720, because for theta it is given it is 0 from 360. So basic angle is 60. This basic angle is again 60. If I'm solving for 2 theta, I know this first angle would be 60. This second angle would be 300. Now this is the point, Mahad, because the domain is forcing you to take another round. That is why we have so many answers. Now this is the third angle. This is 360 plus 60. That is 420. Yes. No, I'll explain it. Just let me write this last answer. This is 720 minus 60. Take away 20, take away 40 is 660. So these are your 4 answers for 2 theta. And for theta, finally, you divide those 2 on the other side. This becomes 30, 150, 210, 330. These are your final 4 answers. Why don't we do that? This is cos of 2 theta. The angle inside the trigonometric ratio has nothing to do with Demas rule. You cannot take this 2 on the other side. If you had this question like 3 cos 2 theta is equal to 1 by 2, yes, you can take this step. 2 theta is equals to 1 by 6. But you cannot take this 2 on the other side and make it 4 or 12. G. Getting it? Okay, now look at this. Tan of 45 minus theta, and we are solving from 0 to 360. And tan theta is equal to minus 1. Tan and angle is 45 minus theta is equals to minus 1 from 0 to 360. Okay, so we solve for basic angle. This is tan alpha is equals to minus 1. Alpha is equals to tan inverse of minus 1. And again we did this triangle. This was 1 square root 2 45. So tan of 1 is basically 45. Yes. Alpha we call it basic angle. I substituted it to find basic angle. Now the basic angle is 45, first thing. Alpha is equals to 45. Second thing, we know that it is negative. And adding sugar to coffee, we know where it would be negative is second and fourth quadrant. So for second and fourth, we already know the basic angle, which is 45, 45 each. And from 0 to 360, there are two answers, 1 and 2. And what are we solving for? This is 45 minus theta. I forgot to convert it. This was 0, theta, and 360. For 45 minus theta, this would be minus 45. 45 minus theta, and take away this angle, or easier way without converting it. I'm just solving for the answers. So if I write this 45 minus theta, this is the first angle 135, and the second angle is 45 less than 360 is 315. So minus theta, take 45 on the other side, becomes 135 minus 45 is 90 degrees, and 45 again, 315 minus 45 is 270, and then you take this the negative sign, so minus this and minus this. Can you quickly check when we substitute this minus 90 in this equation? Yes. Yes, that is it. Can you quickly punch tan 270? Can you punch tan 270? Method, okay. So basically it is less than that at 1045. And when you substitute 315, Tan of 315 is -1. Sorry, that was my mistake. It is not 270. 90 plus 45 is 135. So tan of 135 again, please. -1. So both are correct. This was not part of solution. This was just a check. I had these two answers and I substituted them back in the main equation right here to see if it justifies. So when I plugged in -90 minus 270 back, so we're getting -1. So both are correct.